It started with a glitch. Not a dramatic one, just a flicker on my monitoring screen at 2:17 a.m., the kind that most people would ignore. But I'm not most people. I've been watching the sky for nearly 20 years, and I've learned that the universe rarely makes mistakes. Humans do. For months, my team at the observatory had been tracking 3I Atlas, one of the few known interstellar objects to cross our solar system. Officially, it was labeled as a faint, hyperbolic comet. Nothing unusual about that. Unofficially, though, things didn't quite add up. The object's path wasn't just fast, it was erratic. Some measurements hinted at small bursts of acceleration, as if something was subtly pushing it from behind. Solar radiation? Maybe. But the pattern didn't match. When I tried to recheck the data, half of it was gone. The storage drive showed an empty directory where 3 weeks of recordings used to be. At first, I thought it was a server malfunction. Then I found out that 2 other observatories had reported similar losses on the same night. No one wanted to talk about it. One colleague told me quietly, just let it go. It's not worth the noise. But the thing is, in astronomy, silence often means someone already knows the answer. A week later, a public statement appeared online. Data inconsistencies regarding Comet 3I Atlas are due to routine calibration errors. That was it. No follow-up, no detailed report, no access to raw data. Just a single paragraph that somehow managed to close the case before anyone could ask real questions. Around the same time, amateur astronomers began to notice something strange in their own images. The tail of the comet, normally smooth and predictable, showed a faint, pulsing light pattern. It repeated every 11 seconds. Some thought it was just sensor interference. Others said it looked like a signal. There's a theory that interstellar comets might carry remnants of ancient planetary systems, dust, rock, maybe frozen gases from dead stars. But this one seemed too organized. Too deliberate. And then came the radar blackout. For about 4 hours one night, several monitoring stations across Europe and Asia went offline, including one of NASA's deep space tracking antennas. No technical explanation was provided. The systems came back up at dawn, and when they did, all new data on 3I Atlas had been reclassified as restricted. It's easy to dismiss these things as coincidences. I've done it myself more times than I can count. But coincidences lose their charm when they start forming a pattern. When I ran my last successful scan before the blackout, I caught something subtle, a faint radio echo that didn't belong. Not natural static, not background radiation. It was narrowband, repeating at intervals just below human hearing range. It lasted less than 2 minutes, then vanished completely. I sent the file to a colleague for verification. A few hours later, his email bounced. His institutional address had been deactivated. He didn't answer his phone either. The next morning, the observatory director called an internal meeting. The message was short. From now on, all observations of 3I Atlas must go through central review. Do not share data externally. No explanation, no discussion. I didn't argue. But I did make a copy of the last scan, just in case. Somewhere, deep down, I know I shouldn't have. But curiosity is what keeps people like me awake at night. And lately, the sky has been unusually quiet. Too quiet. 3 days after the blackout, I drove to the mountain observatory myself. It's an old station, built in the late 70s, full of creaking doors and analog memories. I'd worked there before. I trusted its machines more than most people. I wanted to verify the orbital parameters of 3I Atlas using raw tracking data, no filters, no central servers. Just my own instruments. But when I arrived, the sky logs for the week had already been archived under a new classification tag, non-public data set. That's an unusual label. Normally, we use it only for government-related space debris or classified satellite trajectories. Not for a comet. I found the technician who handled the archives, a quiet guy named Lewis who smoked more than he spoke. He looked uncomfortable the moment I mentioned 3I Atlas. They told me to lock that folder, he said, without meeting my eyes. Who told you? He shrugged. Someone from the central office. Said there were security considerations. I didn't ask. Security considerations. For a comet traveling millions of kilometers away. I went back to my console and tried to retrieve orbital data from an independent tracking network, a small group of universities that still shared information informally. But even there, some files were missing, replaced by placeholders that read data temporarily unavailable. The timestamps were identical across multiple sources. Someone had synchronized the erasures. Later that night, I ran a manual cross-check of the object's position based on visual observation submitted by amateurs. That's when I saw the discrepancy. According to their logs, 3i Atlas had deviated slightly from its predicted course, just a fraction of a degree. But at the scale of interstellar motion, that's enormous. It meant something had influenced its path. Solar wind fluctuations could explain it, in theory. Except the solar readings from that period showed nothing unusual. No flares, no radiation spikes, nothing that could produce that kind of drift. I shared the findings with a friend of mine in Prague, an astrophysicist named Pavel who still had access to the European Space Agency's internal telemetry reports. A few hours later, he sent a short encrypted message. You're right. It's moving differently. But don't ask how I know. He didn't answer any more after that. Over the next few weeks, a quiet unease spread through the community. Some researchers started avoiding the topic altogether. Others dismissed everything as data noise, pretending not to notice the inconsistencies. But late at night, in private chats and encrypted forums, the same questions kept surfacing. Why were the readings incomplete? Why had several observatories suddenly lost access to their own archives? And why did the object's brightness keep fluctuating in a pattern that didn't correspond to any known cometary activity? There's a theory, unofficial, of course, that interstellar comets might contain metallic cores or reflective surfaces that produce unusual albedo changes. But some analysts noticed something else: the light variations weren't random. They followed a repeating interval, almost like a slow pulse. A few posts appeared online claiming the pattern matched specific communication frequencies used by deep space probes. The posts vanished within hours. Screenshots remained, but the accounts that posted them were deleted. Around the same time, I received a plain envelope at my office. No sender address, no note, just a flash drive. Against my better judgment, I plugged it into an isolated machine. Inside was a single image, the high-resolution telescope capture of 3i Atlas taken about 2 weeks earlier. Only it didn't look like a comet. The nucleus wasn't spherical. It had edges, faint, blurred, but unmistakably geometric. A hexagonal outline, barely visible under the glowing coma. I ran an analysis to check for digital manipulation, but the metadata was clean. It came from a verified observatory camera. I tried tracing where it had been taken, but the image header listed the coordinates as a classified sector. I'd never seen that label used in civilian astronomy. By the end of the week, the drive itself disappeared from my drawer. I don't remember taking it home. I don't remember giving it to anyone. But it was gone. There's a saying in this field: the more data you lose, the closer you are to the truth. I used to think it was a joke. Now I'm not so sure. I began documenting everything privately: timestamps, discrepancies, system anomalies, missing correspondences. I even printed some of it out, thinking maybe paper would be harder to erase. 2 days later, the observatory issued an internal directive banning all external data sharing about non-planetary interstellar objects. The notice didn't mention 3i Atlas by name, but everyone knew what it meant. Somewhere in the middle of all this, I caught myself staring at the night sky longer than usual. It was strange, knowing that one small object, invisible to the naked eye, had managed to unsettle an entire network of scientists without a single official announcement. There's a fine line between curiosity and obsession. I was beginning to cross it. Still, I couldn't shake one thought. If 3i Atlas wasn't behaving like a normal comet, then maybe it wasn't one. It's strange what you start to notice once you stop trusting the official channels. After the directive came down, I decided to build a small setup at home, an independent monitoring rig using an old parabolic antenna, a broadband receiver, and a few modified software tools from the observatory. Nothing fancy, but enough to track a faint signal if one was really there. For weeks, I scanned the patch of sky where 3i Atlas should have been. At first, nothing. Just static. Then, on a cold, sleepless night around 3:40 a.m., I caught something. A narrowband frequency spike at 1420. 7 MHz, the hydrogen line. The same frequency SETI projects have used for decades to search for intelligent signals. Coincidence? Possibly. But the signal pulsed. Not rhythmically, like a pulsar, it was irregular, with subtle pauses, short bursts, almost like data packets. I recorded 12 minutes before it vanished. When I tried replaying it through the analysis software, I noticed an odd modulation pattern, 3 repeating peaks, then silence, then 3 again. I overlaid it with the light curve data from the comet's recorded brightness, the same 3-interval pattern. I sent a copy of the file to a trusted contact in Chile, an engineer who used to work on radio telescopes. He called me 2 days later, voice low and tense. "Whatever that is," he said, "it's not noise." "But you didn't get this from a comet." When I asked what he meant, he paused. "There's already a similar signal on record." From 2019. It was logged during the passage of 2i Borisov, the other interstellar visitor. Different object, same modulation frequency. I searched everywhere for confirmation, but no such record exists in any public database. Not one. Yet the metadata he sent me matched internal observatory formatting down to the timestamp style. Someone had buried it deep. Around that time, strange things started happening online. A few independent researchers began posting discussions about an unexplained radio correlation between 3i Atlas and earlier interstellar objects. Those posts disappeared within hours. Forums were scrubbed clean, threads locked, accounts suspended. One user wrote before vanishing, "It's not from the comet. It's from what's following it." A week later, I received a call from a number I didn't recognize. The voice on the other end was calm, almost emotionless. "You're digging in places you don't belong," the man said. "Delete your recordings. Focus on something else." Then he hung up. I laughed at first. It sounded absurd, like something from a bad conspiracy film. But when I went to check my observatory credentials the next morning, my login was disabled. My access to the data servers had been temporarily revoked pending administrative review. That same day, an internal memo circulated among astronomers, subtle but clear. It reminded staff that unauthorized data acquisition outside approved channels could result in suspension of research funding. No mention of 3i Atlas, of course. Just a coincidence. That evening, I met with an old friend from grad school, someone who'd gone into defense contracting. We sat in a quiet bar at the edge of town. He didn't drink much, just stirred the ice in his glass and spoke without looking up. "You didn't hear this from me," he said, "but part of the reason data is restricted isn't just security. There's concern about panic." "Panic about what?" He hesitated. "Trajectory. The models don't match. Some think it's on a return path." I stared at him. "Return path? It's hyperbolic, it shouldn't return." He just nodded slowly. "That's what the models say. But maybe the models are wrong." He left before I could ask more. For days, I couldn't think about anything else. I rechecked every simulation I'd ever run on the comet's orbit. A hyperbolic trajectory means escape. Once gone, it never comes back. But if the object's acceleration wasn't purely gravitational, if something else was guiding it, then return wasn't impossible. Unlikely, yes. But not impossible. I began noticing subtle changes in the available starfield data from space-based telescopes, specifically, small gaps in image archives during 3i Atlas's approach. In some cases, entire sky sections had been replaced with new imagery only a day after publication. The new files had perfect metadata, perfect calibration, almost too perfect. It was as if someone had rebuilt the data from scratch. When I reached out to a former ESA technician about it, he replied cryptically, "They're cleaning frames." You didn't hear that from me. Cleaning frames. I'd heard that phrase once before, years ago. It referred to the process of removing classified objects, like military satellites, from astronomical images before release. But what classified object could possibly share a field with a comet coming from another star? There's a whisper going around that Three-Eyed Atlas wasn't alone. That deep space sensors tracked a smaller, dimmer body moving behind it, same velocity, same direction, as if tethered. No one talks about it publicly. No one denies it, either. I've stopped trying to convince anyone. I just keep writing notes, documenting what I can. Because one day, when the official narrative changes, and it will, I want someone to remember that there were people who saw the gaps, who noticed the silence. And lately, I've been getting the feeling that the silence is intentional. The last real data I ever received came through at 1:12 a.m. on a Tuesday. It wasn't from my home rig, or from any official network. It arrived through an old relay node I'd set up years ago for testing. A faint signal burst, 2.3 seconds long, from the exact coordinates where Three-Eyed Atlas should have been. The waveform wasn't like the previous hydrogen line spikes. This one was lower, denser, as if carrying layered information. When I ran it through a basic FFT filter, something strange emerged. 3 narrow peaks again, but this time, each peak carried a harmonic pattern. Together, they formed a ratio close to 1:1. 618:2, 618. The golden ratio. I don't believe in cosmic coincidences. Not after everything I've seen. I tried to share the file with my Chilean contact, but the transfer failed repeatedly. The system threw back a restricted route error, even though it was my own private connection. When I checked the local logs, there was an unfamiliar IP address listed under active observers. I disconnected everything immediately. That night, the power went out across the entire neighborhood for almost 15 minutes. The official cause, routine grid maintenance. Maybe. But I still remember the timing. The next morning, my email inbox was empty. Every message related to the project, gone. Drafts, attachments, even backups in cloud storage, wiped. My credentials on multiple astronomy databases no longer existed. My name had been quietly removed from the Three-Eyed Atlas observation records. As if I'd never been part of it. It's strange, when you lose access to the data, you start questioning your own memory. Did it really happen? Did I misread the numbers? Was it all just an illusion of pattern seeking? That's what they count on, I think. Doubt is the cleanest eraser. Later that week, I received one final message. Not by email, printed, delivered by hand, slipped under my door. It read, "Cease all private transmissions. Three-Eyed Atlas will not reappear. Observation terminated." No signature. Just a black watermark, faint but visible under light, a triangle enclosing a dot. I'd seen that symbol before, once, on a restricted document about orbital defense protocols. After that, I decided to stop. At least officially. But habits die hard. And so do questions. I kept one backup, a physical drive, hidden far from the observatory, containing the raw signal files and the geometric image of the comet's nucleus. I don't know what it means. Maybe nothing. Maybe everything. Sometimes, late at night, I still monitor the sky. Not through official channels, not through public feeds, just my old receiver humming in the dark. The static feels comforting now, like the heartbeat of something immense and ancient. 2 weeks ago, while running a casual scan, I picked up another faint echo near the edge of the Perseus arm, weak, intermittent. The same 3-interval pulse, but slower, almost like it had aged. According to every orbital model, Three-Eyed Atlas should be long gone by now, drifting endlessly beyond the heliopause. But the echo's origin point didn't match that projection. It was closer. Too close. I shared the coordinates with no one this time. No papers, no calls, no colleagues. Just me, sitting in the half-light of my small office, listening to the universe whisper back. There's a rumor circulating quietly through the community, not in public forums, but in whispered chats, private calls, encrypted messages. They say that, weeks after 3I Atlas disappeared, several military tracking stations detected a secondary object entering our system, one with almost identical velocity and spectral signature. The reports never went public. Some think it's debris. Some think it's a misreading. A few think it's something returning. I don't know what to believe anymore. I only know what I've seen, and what's missing. There are still small gaps in the night sky, are places where data should exist but doesn't. Dark zones in satellite maps, misaligned timestamps, repeated image headers. They look like errors, but they aren't. They're omissions. Intentional ones. And whenever I bring it up, people smile politely, change the subject, or tell me I've been staring at the dark too long. Maybe they're right. Maybe I have. But sometimes, when the air is still and the receiver is quiet, I swear I can hear it again, the faint rhythmic pulse buried in the static. Not a sound, exactly. More like the suggestion of one. 3 intervals. Pause. 3 more. I once told a student that astronomy was the science of patience, of watching and waiting. I still believe that. Because whatever 3I Atlas was, Comet, probe, or something in between, I have a feeling we haven't seen the last of it. And when the signal returns, someone will need to be listening. Whether that someone is me, I don't yet know. But I keep the antenna powered on. Just in case. After all, silence doesn't always mean nothing. Sometimes it's the universe deciding who's ready to hear.